Hi, AB Calculus class. We are working on the packet that says May 1st, and it just topically arranges everything. So everything that we're working on today from May 1st, the topic is FTC, the fundamental theorem of calculus. So they're all going to have something to do with a graph, kind of like this. Okay, so let's go ahead and start with part A. So part A, before we get started, they tell me this is the graph of f, but they give me this. If you are given this before you do anything else with the question, you need to get more information by taking the derivative. So we're going to take the derivative. The derivative of g of x is g prime x, and on the other side we're going to take the derivative. And the derivative destroys the antiderivative and x jumps in. So derivative destroys the antiderivative, x jumps in, and now we know that this can be called f of x. From here we're going to take the derivative one more time, and we get the second derivative is f prime x. Okay, now this is important for one very big reason. They are saying this is the graph of f, but here we see that f can also be called g prime x. So we can also call this the graph of g prime x, and that's going to be huge. Because remember, if you have a graph of the derivative, if I have the graph of g prime, I can make a sign chart of g prime, and then take its derivative and make a sign chart of its derivative g double prime x, and that will answer most questions that they're going to ask. Okay, so let's go ahead and look at part A. Part A says find the value of g of 2. Okay. Well, to find the value of g of 2, notice g of 2, we're not down, not these two, g of 2 are right here. G of 2, we're just going to put a 2 right there, is the area from 1 to 2 of f. So we have to find the area from 1 to 2. Okay. Now the area to 1 to 2 is this little triangle right here. And you might wonder, well, Mr. Pygott, how far down is this? Well, if this is a height of 0 and this is a height of -1, then this right here is going to be a height of 1/2, okay? Instead of going down all the way 1, this just goes down a half. All right, so the area from 1 to 2 is the area of this triangle. Now the first thing, it's below the curve, so the area is going to be negative. And now a triangle is 1/2 base times height. So the base of this triangle is 1. And the height of this triangle is 1/2. And I'm done. You do not need to simplify this. Remember, the AP exam is all free response now, which means leave your answers unsimplified. Could I simplify this and make it -1/4? Yes. But that's my answer. I'm not going to simplify anything. And you've got to get in the habit of not simplifying stuff. Because if you simplify and you mess up, you just throw away points. There's not going to be a lot of points on the test either. Maybe 27 points. You know, you don't want to throw away some just because of calculation error. All right, the second part says find g of -2. So we're still in this equation here, so it's from 1 to -2. Now, the first thing you'll notice is these are in the wrong order. So we've got to flip it, and the price to pay is a negative in front. Go. All right, so our answer, g of -2, is going to be a negative being multiplied by whatever we get here. So we're going to find this area and put it in. Okay, so I'm going from -2 to 1. Well, in order to get from -2 to 1, I'm going to start with this triangle right here. The triangle that's above the curve, so it's going to be positive area, and 1/2 base times height. So it's 1/2 base times height. The base is 1, the height is 3. Base is 1, height is 3. We don't do anything else. Okay. Plus, and now we need, to finish going all the way to 1, we need the area of this. Now you'll notice this is below the curve, so this second area is going to be a negative. In fact, I could just get rid of a plus and just put minus because it's below the curve. So minus, and notice it's half a circle. So it's half a circle, so 1/2 pi r squared. So all I need is the radius, and the radius of this semicircle is 1. Now, if you look online, they greatly simplify it. You don't want to simplify it. You're done. You've got your points. The area from 1 to -2, the first thing we did was flip it, put a negative in front, and now we have this negative, and we just found the area of the triangle and the area of the semicircle. The semicircle counted as negative area because it was below the curve. Okay, so that's all we're doing for part A. So now we're going to go to part B. All right. For part B, they ask us to find G prime -3. So G prime -3, we're going to use this equation here. G prime -3 is just f of -3. And this is the graph of f. So f of -3 simply wants the ordered pair at -3. So if you go to -3, -1, -2, -3, they simply want to know what that ordered pair is. Now, let me get rid of some of this stuff. Again, you're having to use some common sense. Here the height was 1, and here the height was 3. So it traveled halfway there, so the height here is 2. So G prime -3 simply meant what is f of -3, or the ordered pair. When the x coordinate is -3, what's the y coordinate? The second part here is what's G double prime -3. And we're using the bottom equation. G double prime -3 is simply f prime of -3. Now folks, if this is f prime -3, if this is the graph of f, f prime means what's the slopes. So we want to know what's the slope at -3. So all we want to know is what's the slope of the tangent line here. Well, you know how to find slope. It's just rise over run. It's a line, so the tangent line is the slope of the line. And if you rise 1, run 1, rise 1, run 1, or you could do rise 2, run 2. But either way, the slope is a positive 1. And that's it. So that's part B. All right. Now time for part C. Part C says find the x-coordinate at each point at which the graph of G has a horizontal tangent line. Okay, now we don't know what G looks like. We don't have a graph of G. We have a graph of F, which is also G prime X. We have a graph of G prime X. But I want you to think, if G has a horizontal tangent line, what is the slope? The slope is 0. Okay? So in other words, if G, this is the graph of G, if G has a horizontal tangent line, its slope, its derivative is 0. Now, one thing about horizontal tangent lines, they can never happen at endpoints. Endpoints can only win absolute max or min awards. They can't be relative maxes or mins or anything. So, I want you to notice that this is the graph of G prime X. Where is G prime X equal to 0? G prime X equals 0 right here and right here. Again, I could call this F, but I could call this G prime. So for the purposes of this problem, we're going to call it G prime. We're going to make a sign chart of G prime. And again, you could call this G prime X or F of X. And my sign chart goes from -4 all the way to 3. And on this sign chart, I'm going to put down a -1 and a 1. These are the only two places where G prime X is equal to 0. It's 0 here, it's 0 here, and then again, sign chart. So it's above the curve positive values, below the curve negative values, below the curve negative values. So my sign chart goes positive, negative, negative. Okay, now, before I answer part C, there's two parts. It says, find the x coordinate where G has a horizontal tangent line. So I would say, G has a horizontal tangent line. You notice, see, I'm giving what they want. I'm answering their question. And remember, it has a horizontal tangent line when the slope is 0. So the slope was 0, or in other words, g prime x was 0 at -1 and 1. So both of these are where the slopes were 0. Now, that's not where the question ends. Now they say, well, go look at each of them. Are they relative maxes or minimums or neither? And that's where we can use the sign chart. So here I'm looking at my sign chart and I'm saying, okay, if g prime x was positive and then negative, that meant g of x was increasing and then decreasing. That's a max. But now over here at 1, it was decreasing and still decreasing. So it was decreasing, slope was 0, and then still decreasing. So if it's decreasing and still decreasing, it's neither. So I would say at x equals 1, sorry, at 1, we'll do -1 first. At x equals -1, g of x has a maximum. I don't like the way that looks still. Okay, so still don't like the way it looks. Okay, there we go. So at x equals -1, g of x has a maximum. And notice they say justify your answers. So I'm going to say because, I'm going to look at this chart and say because this g prime x, you got to tell me what graph or what sign chart you looked at. So because g prime x changed from positive to negative values. Changed, switched, so changed from positive to negative values. And now I'm going to answer the next one. At x equals 1, it was neither a max or min. It was decreasing and still decreasing. So I'm just going to write neither, and then because g prime x, and I can just say simply g prime x didn't change signs, or it was negative and then negative. But just g prime x didn't change signs. And there you go. But notice this question had two parts. First, they wanted to know when it had horizontal tangent lines. Remember, that's where the slope is 0. I answered that question. And then I answered the second part. At these points, are they maxes or mins? A lot of time people will skip this first part and they'll just go to answer these questions and they throw away points. And one quick thing to remind you, endpoints could not have been horizontal tangent lines, could never have been these endpoints. Even if this was at 0 here, even if this was at 0, endpoints are never horizontal asymptotes. Okay, let me go ahead and erase this and we'll go do part D. Okay, part D says find all values for which g has a point of inflection. Just like maxes and mins, relative maxes and mins and points of inflection, it can't be endpoints. Now, if you want to know where something has a point of inflection, you would want a sign chart, not of the first derivative, but of the second derivative. Now, think about what features we're going to look at. Right now, we have the graph of g prime, and we want a sign chart for its derivative, g double prime. G prime, g double prime. We want to know what features of the graph of g prime tell us about its derivative, and the answer is slopes. So we need to look, where are these slopes positive or negative? So, positive slopes until we get to -2. So until we get to -2, we have positive slopes. And then we have negative slopes all the way to 0. So we have negative slopes all the way to 0. And then we have positive slopes until we get to 1. So positive slopes until we get to 1. And then lastly, negative slopes. So my slopes were positive, negative, positive, negative. Okay. Now, this is my sign chart for the second derivative if concavity. The second derivative tells us about concavity. So g would have been concave up, concave down, concave up, concave down. If concavity changes, these are points of inflection. So we would say points of inflection at x equals -2, 0, and 1. They're all points of inflection because, and if you have to label your sign chart. So you can look at your sign chart and say g double prime x. So because g double prime x changed signs. Or you could say from positive to negative or negative to positive, but just change signs at these points. Done. Okay, so that's an FTC question. You're going to get several more today, and hopefully you'll get really good at it. All right, bye.